OpenAI, Azure OpenAI, LLaMA, OLLaMA, ONNX, Windows AI Foundry, Copilot Studio, Semantic Kernel. New AI technologies seem to show up faster than we can learn what they actually do. If you're unsure what you need to know to add AI to your apps, or why all tech leaders are so obsessed with it, you're watching the right video, because today we'll break down all the main AI technologies available for .NET developers. We'll look at real-world user scenarios beyond just fun stuff like telling pirate jokes. I've grouped all AI technologies into three categories: cloud, local, and integration. Let's start with cloud and the capabilities offered by OpenAI. A bit later, we'll also talk about how OpenAI differs from Azure OpenAI. Yes, there is a difference. The heart or the brain of OpenAI services is the capability to use cutting-edge large language models, or LLMs. Depending on what you need, you can choose from multiple types of models. Chat models like GPT-4 are great for understanding text, analyzing it, and generating intelligent responses. Reasoning models like Omni-series are designed for more complex tasks like planning, problem solving, and digging into things like math and legal documents. You've also got models for generating images, creating speech from text, or transcribing voice to text. And finally, there are embedding models, which are used to measure semantic similarity, basically finding how close two pieces of text relate in meaning. You can access all these models in code. For instance, to use a chat model, you need to create a chat client instance with a model name and your key obtained from the OpenAI portal. Then you can use the client to send and receive messages. For real-world business tasks, you'll often build an AI agent with tools, access to your knowledge base, and connections to other agents. We'll cover that later. But in many cases, a standalone model is enough. You can do all kinds of text tasks such as correct errors, summarize text, rewrite content, translate, change tone and format, or suggest the next word. Research models let you analyze data in Excel documents, review legal documents, examine scientific papers. With audio-to-text models, you can analyze call center data, enable voice commands, or transcribe patient complaints in healthcare. You can transform text to audio to create agents for e-learning lessons, or generate responses from smart devices. For example, let your coffee machine remind you that it's 2 a.m. and maybe it's time to stop coding. You can use semantic search based on embeddings to identify similar support requests, or for instance in healthcare, to find relevant literature using non-standard symptom description. As I mentioned earlier, OpenAI models are just the core. For full-featured AI solutions, you may often need to create an AI agent, something that can call tools, keep conversation history, and access private data. Agents let you define tools like web search, file search, custom functions, or even running Python scripts. There is also a new feature called computer use, which lets agents interact with your user interface directly. In .NET, you can access this functionality through the Agents and Responses API using a dedicated C# library. But we'll explore other ways to build agents in this video, so be sure to check them out before you start coding. Let's take a look at a few user scenarios. One of the most popular is adding domain-specific knowledge to model responses. This is usually referred as Retrieval Augmented Generation, or RAG. It enriches agent replies with your own data, which is great for creating a sales assistant with access to product information, internal company knowledge base, or support assistant aware of documentation and FAQs. If your agent needs the latest public information from the web, you can use the built-in web search, for instance, to analyze competitors, track news, or help HR compare job offers. Agents can call custom functions to get user location, send an email, or fill out a form upon user request. You can configure your agent to execute Python code dynamically, to read and visualize Excel file, generate reports on the fly, or calculate complex values. Finally, you can enable computer use. This gives agents access to your machine so it can analyze screenshots and automate such tasks as filling out multi-step forms. You can use this feature for onboarding users or running end-to-end UI tests. It can be useful when communicated between applications or when an agent needs to interact with a legacy application. Now let's talk about OpenAI's fine-tuning. A bit later, I'll explain when to use it instead of RAG. But first, here are the three main techniques you can use to fine-tune OpenAI models. Supervised fine-tuning. Here you provide input-output pairs, and the model learns by being rewarded when it generates the correct response. Direct preference optimization, or DPO. where you compare two model outputs and mark which one is better. You've probably seen this in ChatGPT when you're asked to choose between two responses. That's DPO in action. Reinforcement fine-tuning. Here you define a grading function that scores responses from 0 to 1. This gives you more flexibility in shaping model behavior based on your own criteria. So when should you fine-tune a model? Fine-tuning can help if your prompts are getting too long because you are providing too many instructions to control the output format. Instead of repeating instructions, you can teach the model the expected format. This cuts down on input tokens so you can pay less. And in some cases, you can even use a smaller and a cheaper model. And of course, fine-tuning can help improve output quality. You can make the model respond in a specific tone or extract information in the format you need. But if you need your model, for example, to answer questions about your company, or if you want to pull information from specific documents, go with RAG instead of fine-tuning. So think of it this way. Use RAG when your model needs to know more. Use fine-tuning when it needs to think or respond differently. So you've chosen the model, added tools and a knowledge base, maybe fine-tuned it. And now the final step is to evaluate the system. The process is pretty straightforward. Describe the task, provide input and expected output data. Then measure how closely the model responds to the expected output. This helps you see if the system is actually solving the problem and how any changes impact the results. Now we know what OpenAI services can do. Let's move to another giant, Azure. It incorporates a lot of AI services, including Azure OpenAI. But first, let's explore Azure Foundry, which is an umbrella for multiple AI products, including models, agents, prompt flows, document processing, vision, search, and language. Just like in OpenAI, the core is the capability to deploy models. There are many popular models here, including OpenAI's GPTs and Omni models, DeepSeek, LLaMA, Mistral. With them, you can achieve all the tasks and even more that you can do with the models in the OpenAI service, such as text operations, research, audio processing, and etc. Next, in Azure Foundry, you can create agents with tools and knowledge sources. In the Foundry portal, you can add both tools and knowledge to your agent and then test in the playground. The usage scenarios for Azure agents are the same as for those for OpenAI agents. You may ask then, why to use Azure if I can use OpenAI directly? The answer is that Azure offers many additional cloud services that can either be incorporated into your AI agents or used in parallel with them. For example, AI agents can natively use Azure Search, apply content filtering, which we'll overview a bit later, and make it easy to limit deployed models to your other Azure deployed resources. Additionally, you can integrate it with Enter ID. Let's move to the next feature available in Azure Foundry, Prompt Flow. It allows you to define what steps should be executed when you receive a certain prompt. For instance, if a user asks for your AI assistant to report a bug, your prompt flow may look as follows. First, you use RAG to find similar issues in your internal database. Then you ask users if any of the found issues match the problem. If users reply yes, suggest trying the solution from the matched issue. If users reply no, use the tool to create a new support ticket. And other user requests can be handled according to a different flow. While you can simply use an agent with tools, a prompt flow will make the response of your entire system more deterministic. It's like a set of rules or steps that employees follow when processing user requests. In Azure Foundry, you can also find the content safety and security feature. Since responses from AI models are not entirely deterministic, it can be challenging to guarantee that users don't receive inappropriate responses or misleading information without additional measures. So you can use content safety to detect aggressive and sexual content, sanitize user input and output, and ensure that the information provided by your agent is grounded in your documents, rather than being a hallucination. Additionally, in Azure Foundry, you can set up a evaluation process to track multiple quality and security-related metrics. Next up are features for extracting structured content from documents, images, video, and audio. In Azure Foundry, you'll find these under Content Understanding. While Azure also offers separate services like Document Intelligence and AI Vision, Content Understanding is evolving more actively, so I think it's a better choice for new projects. With Content Understanding, you define the fields you want to extract, and the service returns the structured output based on your schema. It's great for tasks like extracting data from invoices, auto-sorting documents for different departments, pulling data from IDs into forms or database, for transcribing and analyzing conversation, like between a salesperson and a client, or a doctor and a patient. You can also detect suspicious activity on CCTV or monitor product placement in warehouses. While you can use a general multimodal AI model for these tasks, specialized content understanding services are more effective when you need clean and structured results. Let's move on to the next Azure product, AI Search. It's great for finding information using either semantic similarity or full text match, and you can combine them with hybrid algorithms to sort the results. The big advantage is that it works with huge datasets like hundreds of gigabytes and still delivers results in milliseconds, thanks to optimization techniques like quantization. With AI Search, you can create customer search portals, add free text search to real estate apps, or integrate it into your agents to build an advanced RAG system. While popular LLMs can handle many language processing tasks, Azure offers specialized language services including named entity recognition, language detection, semantic analysis and opinion mining, and more. Most of these services were created before the active LLM expansion, so today, in most cases, I think I'd prefer a language model for these tasks. There are other Azure AI products out there, but we've just covered the most important services. Now let's move on to Copilot Studio, which is separate from Azure. Copilot Studio is a low-code platform for building AI agents that integrate directly into Microsoft 365. You can add knowledge sources to set up triggers for agent activation, create custom tools in processing flow, and deploy your agents to various internal and external channels like Teams, Facebook, Microsoft 365, Copilot Chat, and more. You can use these agents to do things like analyze emails sent by your sales team, create internal agents that answer questions about your knowledge base, or external agents that handle FAQs. Copilot Studio is a great alternative for fully functional Azure-based agents if you want tight integration with Microsoft 365 and you don't need advanced customization. We wrapped up cloud-based services, so let's move on to local solutions. Here you'll learn how to use cutting-edge models for free and run ML models directly on end-user machines without an internet. So let's start with LLaMA.cpp and Ollama. Both let you run pre-trained AI models on your own computers, whether it's server or end-user device. You can easily host models like DeepSeek, Llama, Mistral, and many more. You don't need any ML experience here, just a few lines of code to get started. Ollama is based on LLaMA.cpp, so in general they're inspired by the same idea of running models locally. With locally hosted models, you can do almost everything you'd get with fancy OpenAI or Azure models. But local models come in handy when you need to protect data, cut costs, or run offline on end-user machines. Both LLaMA and Ollama are open source and free, so you can use state-of-the-art LLMs without paying anything, except for electricity. Another great framework for working with local models is ML.NET. It lets you work with pre-trained ONNX models through ONNX Runtime, and even train your own models without deep AI expertise. ONNX is an open format for AI models, so you'll find tons of pre-trained models for tasks like object detection, face recognition, image classification, OCR, and more. Plus, you can convert from popular frameworks like TensorFlow, Keras, and PyTorch. Here are a few examples where ONNX models can be useful. You can classify images with specialized models, detect objects with autonomous vehicles, track objects on warehouse shelves, or provide product recommendations in e-commerce. The key difference between ONNX and Ollama compatible models is that ONNX covers all types of models, not just LLMs. While some Ollama models can handle video and audio input, they're not as fast and effective as ONNX models designed for these specific tasks. But if pre-trained models don't meet your requirements, you can create your own with AutoML and Model Builder. While simple models may not compete with fancy general-purpose models in complex tasks, they're great when you need to predict values from structured data. For example, you can forecast sales based on historical data across multiple parameters, detect fraud, or segment data for some insights. Next on our list of local solutions is Windows AI Foundry. Is it just me, or are there way too many AI Foundries showing up? Feels kind of scary. Anyway, Windows AI Foundry is a toolkit for using built-in or downloaded ONNX AI models. It requires a Copilot Plus PC with an NPU though. In most cases, its application area is similar to ML.NET, but personally, I'd go with ML.NET because it's cross-platform and doesn't need a Copilot Plus PC. Our last section is integration. You've probably already heard about Semantic Kernel. It's a framework for building agents and custom processing flows in code. With it, you can define an agent in C#, specify the AI model, the functions, and the knowledge base, or connect it to an MCP server. With Semantic Kernel, you can use agents defined in Azure Foundry, or vice versa, create an agent in C# and it will appear in the Foundry portal. So Semantic Kernel makes managing your agents from code much easier. You can define functions in C#, control how agents communicate by creating agent chats, or even use locally hosted LLaMA models. If you're building an agent solution with dotnet, I'd recommend Semantic Kernel because it's service agnostic and very flexible. You can start with a cloud model to test your idea, and then switch to a local LLaMA-based solution to cut costs or for data privacy. The main downside is that it's still under active development, and new versions often bring API changes. There are also a couple of other frameworks for building AI agents and custom flows, such as AutoGen and LongChain. While both have .NET libraries, they're more popular among Python developers. In short, LongChain lets you define steps and logic for processing prompts and data, something similar to Azure's prompt flow. AutoGen focuses more on orchestrating multiple agents. If you're curious, it's worth diving deeper into these frameworks, but again, as a .NET developer, I'd start with Semantic Kernel. Next on the integration list is MCP, or Model Context Protocol, which now has an official SDK for .NET developers. Everyone is talking about MCP these days, but if you haven't heard about it, it's basically just a unified protocol for your AI model to talk to external tools. You can set up your own MCP server, define custom functions, and have your AI agents or even third-party agents communicate with your service. You can also connect third-party MCP services to expand your agent capabilities. With a setup MCP server, you can, for example, let your AI agents manage orders on your server or integrate them with Google Drive or Slack, since third-party MCP servers for them already exist. There is a GitHub repository where you can find many interesting examples of MCP servers. To integrate your AI solution into your user interface, you might need specialized controls and features that support AI. Let's see what's available for .NET developers. Standard Blazor and MVC Smart components offer features like Smart Paste, Smart Autocomplete, Combo Box suggestions, and local embeddings for semantic similarity search. There is also a standard Blazor project template that includes a basic AI chat control. On top of that, component vendors like DevExpress, Syncfusion, and Telerik offer powerful controls for AI integration. For example, there is the AI chat control for WPF, WinForms, and Blazor, semantic search in data grids, ribbons, and editors, text processing features in PDF viewers and rich editors like proofreading, translation, and summarization. Also, text editors allow users to predict the next word. To enable these features, you just need to register your cloud or local AI model in the application. So these components and features let you incorporate AI agent chat into your user interface, speed up email writing with smart text tools, work with PDF, Word, and Excel documents more productively, or help users fill out forms faster with Smart Paste. And that brings us to the end of our huge diagram. Of course, it doesn't cover every AI technology you can use in .NET, and I'm sure new products will keep popping up since so many companies want to get into this space. While they're all busy competing, we get to think about how to actually use AI in our apps. Industry experts are saying that AI agents are going to be everywhere. Sometimes it feels that companies are exaggerating this because they're selling AI services, but I genuinely believe that AI will become more and more integrated into our lives and software. Imagine you've traveled just a few years into the future. How do you see AI integrated into your apps and daily life? What tasks can it handle, and what routine work can it replace? Please share your ideas and probably experience in the comments, and I'll update the diagram to help other users with your insights. Thanks for watching, and remember, we're all just prompts.